So currently, if you check it, we are making a quadcopter drone. And the firmware is also quadcopter. Okay, so make sure the firmware and the drone is the same. Once you've done that, you need to go to the setup. You need to go to the mandatory hardware. You need to go to the frame type, and here the frame type is quad X type. Okay, then there is called accelerometer calibration. So to do the accelerometer calibration, you need to keep the drone like this frame. To do the accelerometer calibration, okay. To do the accelerometer brightness touches.
Okay, sir.
To do the accelerometer calibration, you need to calibrate, and you need to keep the drone and the GPS at the level. Once it was done, you need to keep it at the left. Then it will ask you to keep at the right, and it will ask you to do nose down. It will ask you to do nose up. It will ask you to do the nose back. It was showing calibration was successful. Right now the accelerometer calibration is successful, and again now right now we are doing the compass calibration. Okay, to do compass calibration we need to rotate it like this, 360 degrees. So the more rotation you do, the more stable the drone will fly. So now the compass calibration is also successful. Now we are doing the radio calibration. So we'll do the radio calibration. Loiter, and the third mode is RTL. Okay, these are three modes we are using right now. Like this, we can use n number of modes. Instead of loiter mode, you can keep any other mode. Depends, it's your wish. Okay, I suggest you to go for stable, loiter, and RTL. When you fly in the stable mode, GPS not required. Okay, that's why I suggest you to go with the stable mode. Okay, and because we want to fly in the GPS mode, we can go for loiter mode. And if the drone get out of control, it must come to the home position. That's why I suggest you to go for RTL. Okay, and fail safe. It was asking battery voltage. I'll keep none. I'll keep battery voltage 0. And the next thing is there is an optional hardware is there. Optional hardware. In this optional hardware, battery monitor is there. In this battery monitor, I'll remove the voltage protection. Okay. So now most of the calculation is done. I'll try to arm it. See. Battery voltage fail safe. You can see the battery voltage is fail safe because they are not using any power module. There is no power module to the drone. Okay, we will keep the battery voltage less. because right now we are giving only 5 volts. Okay, but it's showing preamp checks, it's showing because of the battery voltage it was not arming. That's why what we are going to do is, we'll go to configuration, we'll go to setup, no, we'll go to full tree parameter list. Okay, there we'll go to preamp checks. See here it was showing arming checks value 1. We are making it 0. Okay, it means though it was if the see when the preamp check is 0, though the compass calibration is done, though the RC calibration is done, if the accelerometer calibration is done or not, it will get armed. Okay, previously it came yellow. Right now you can check it's blue. And I was arming. Okay, it showed armed. It showed armed because arming checks are disabled. Bad battery. So it's disarmed. Again it's armed. Okay, it means the motor starts spinning. Okay, I have, see, for the small drones, for the F450 and F550 drone, there may be some errors because of the voltage production. Sometimes the accelerometer will calibrate or may not calibrate. Sometimes the compass will calibrate or may not calibrate. At that time, you can go for preamp checks 0. Okay, and the chances of flying drone is 50%. Okay, if you want to fly the drone perfectly, you need to make sure every calibration is done perfectly. So the major 4 steps in the mission plan is: first step, firmware. If it is a quad, it need to be quad firmware. If it's a hexa, it need to be hexa firmware. And second thing is frame type. And third thing is accelerometer calibration. And fourth thing is compass calibration. Fifth is RC calibration. Sixth is flight modes. Seventh is voltage protection. And then you need to arm the drone and see. Still there is some kind of error. Sometimes it will show bad AHRs. Okay, then you need to make sure the GPS is properly fixed at certain height or not. Sometimes it will show a compass error or something. So that's why for the small drones you can go for preamp checks 0. Okay, then the sensors are calibrated or not, also the drone will fly. That to 50-50 chances, we need to, it's a trial and error kind of thing. Okay, this is the standard methods we will follow. Okay, and furtherly we can go to n number of settings. We can give servo motors to the auxiliary pins. We can make the drone to follow us. There are a lot of possibilities are there with the Pixhwak flight controller. So for the beginners, this is how you need to make the drone with the Pixhwak flight controller. Okay, now we will fix the drone to the frame.